This is the one that you were asking about. So loudness and frequency.
The loudness is the amplitude, the pitch is the frequency.
Yeah, so you would expect them to ask you to draw the graph. The pitch is how high the sound is. Like if it's a pitch of a note, then you have how high the note is, how sharp the sound to your ears. Then it depends on frequency, which is already involved. Then in this case, right, you will see your graph down here. The first one, this one has a low frequency. So if it has a low frequency, then it has a lower pitch. Then the other one will have higher frequency, so it has
frequency, higher pitch.
Yeah, higher frequency, higher pitch. So then they are not directly proportional. Okay. So this means, right, if frequency times 2, right, increase, right, then the pitch, right, will not increase times 2. So if frequency double, the pitch will not double. It will just increase or decrease if the frequency change. Okay. So if the frequency is reduced by 2 times, the pitch will not reduce by 2 times, because they are not directly proportional. Yeah. So what the human can
hear. 20,000 hertz.
Yes. So this is what the human can hear. 20 to 20,000.
What's a mole?
A mole is this. That's the mole. It's a creature. It's an animal. And this mole is not the mole from your chemistry. It's a creature that lives underground, I think. So if its frequency lesser than 20 hertz, it's called infrasound. If its frequency more than 20,000 hertz, it's called ultrasound. So you can see that the mole and the elephant can hear sounds that we cannot hear, because
infrasound.
So it can hear infrasounds that we can't. And yeah, so it's a lot there. And you can hear part of it that humans can hear, you see.
And the cat and dog can hear ultrasound.
Yes. And you can hear what we can hear. Then
the bats and dolphins also can hear ultrasound and what we can hear.
Yeah, part of what we can hear. So at different creatures, different animals, they can hear a different range of frequency.
Different people also are able to hear different range. Like younger people can hear higher range.
So it's not constant. So then loudness. So loudness.
The higher the amplitude, the higher the loudness. The louder is.
Yes. But again, like frequency and pitch, amplitude and loudness is also not directly proportional. So increasing the loudness 2 times, not increasing the amplitude 2 times, does not mean that the loudness will increase 2 times. Okay, so we have this question. The answer is there already. So I say you are given this displacement time graph of a particular sound. Then they say you are supposed to draw the same diagram where the frequency is doubled, but the loudness remains the same. Frequency is doubled means you have 2 times the number of waves. No, you cannot do this. What you must do is like this. You must look at this. 1, 2, 3 waves. So frequency double means you have to draw 6 waves inside this space. You must draw 6 waves within that tiny space. If you extend out like what you did just now, then you are not doubling the frequency. You probably just double the time. Okay? Somewhat it's difficult for you to draw like that, but so then the loudness remain the same, so that means the height must remain the same. So then you will draw in between that space with the same height. Okay, they will ask you to draw. All right, then this one 7B, they say draw on the same diagram. Loudness is half, frequency remains the same. So you have the same number of waves. So there are 1, 2, 3 waves here. So you draw 3 waves, same. Then you must measure the height as half. Okay, then another one. Draw on the same line which represent the displacement of the particle when the wave is half the frequency, twice the amplitude. So what you should get is half the frequency. That means down here we have 1 wave, 2 waves, 3 waves. So half the frequency, that means within this window here, you must draw 1.5 waves. Then twice the amplitude means the height of your wave times 2. So 1.5 wave would mean for every 2 waves, it becomes 1 wave. So here, like that one. Then after that, you will have like that only. Okay. So your intersection points are important. These intersection points are important. Okay. The diagram shows displacement of the particle as sound waves passes. So they asked you what happens. So frequency is half, then the pitch become lower. Not pitch is half. Careful of the wording. Then what happens if the amplitude is doubled? Then the sound becomes louder. Loudness increase. Loudness increase. Sound becomes louder.